And welcome back, Algebra students, and we are in Chapter 1, Section 2. Today we're going to cover two sections. We quickly move through Chapter 1 because it is a big review chapter, as are the next two. So you are very familiar with this. This is order of operations. When you think order of operations, what acronym do you think? More than one operation, and the acronym is PEMDAS, right? And so let's think about what the letters represent in the acronym PEMDAS. Whenever you see multiple operations, the first thing you're looking for is P. P represents parentheses, right? Or grouping symbols. So it could be a big old fraction bar. It could be brackets. You may have multiple parentheses. In that case, you go to the innermost parentheses, right? But in any case, we're looking for any kind of grouping symbol. A square root symbol is a grouping symbol. That's called a radical. So there are a lot of different grouping symbols. And so P represents all of those. E stands for exponents or powers. So if there is an exponent, you simplify it next, right? M and D are both red because as we read the operations left to right, either of these, whichever comes first, left to right, you would want to do next. And M and D represent, what do they represent? That's right, multiplication and division, okay? And the final operations that you complete when looking at multiple operations are A and S, whichever comes first, left to right. A and S stand for addition or subtraction. So let's try a few, and then we'll move on to section 1.3. So go ahead and pause, try it out, come back. So in this case, you should have simplified the exponent first. 3 squared is 9, and 10 plus 9 is 19. Okay, now we have multiple things going on here. So P, there are no grouping symbols. E, oh, I see an exponent. So we would want to take care of that first, simplify it. What is 2 to the third? 2 times 2 times 2. Well, that's 8, right? So we would end up with 16 minus 8 and plus 4. Okay, now as we look at this, we say, what do we do first? I have subtraction and addition. Well, PEMDAS tells us do either of those. Do the first one that comes from the left, right? So left to right, 16 minus 8 is 8. And then 8 plus 4 is what is left. And so we have 12. So your answer here should be 12. Remember, this is an expression, not an equation, so I see no equal sign. I just come straight down and simplify on each line, right? Okay, go ahead and pause and try these two. Come back when you're ready to see. Okay, so the first one, we again have an exponent there, so we have 28 divided by, I'm going to have to use a fraction bar to show that, 2 squared, which is 4, plus 1. Okay, so now what do we do first? Do we do the division or the addition? Well, PEMDAS, recall PEMDAS says multiplication and division first. So 28 divided by 4 is 7, and 7 plus 1 is our expression, which can be simplified to 8. Okay, and finally, in this case, you should have done 5 squared, 25. 4 times 25 is 100 plus 4, and the answer then is 104. So that's our quick section 1.2 order of operations, and we're now going to turn to section 1.3. In 1.3, we are writing expressions, which we have done over and over again in the past few years. So writing expressions for some verbal sentence. So we take words and translate them to math. So I want you to brainstorm some key words that represent the operations, the 4 basic operations: addition, subtraction, multiplication, and division. Set your page up like that and jot down at least 2 keywords that would tell you, I'm talking about addition here, or you're talking about subtraction, multiplication, or division. Come back when you're ready to fill it in with others. Okay, so when I do this live with a class, we start jotting down the words that you come up with, and here are some that a previous class came up with. And let's see if I can get this screen to move. There we go. So plus, 3 plus 2. You know we're talking about addition. Added to. 2 is being added to 3. Is another addition. Add. Find the sum. Sum, again, is addition. The sum of 2 and 3 is 2 plus 3, right? Total. Find the total of 2 and 3. Or how about increased by? So 2 is being increased by 3, which means we're adding 3, right? There are so many addition words. More than. I have 3 more than 2. Again, addition. What do I have altogether? If I have 2 and 3 altogether, I have 5, right? So there are 8 short phrases or words that represent addition. You may even have others we could add. Subtraction. Subtraction, rather than plus, we might say minus, right? Or decreased by. I have 10 and I'm decreasing it by 3. What do I have now? Well, I have 7, right? So I'm subtracting. Take away, less than. Susie has 8. I have 4 less than her. So that means I must have 8 minus 4, right? Or 4. Subtracted by, or find the difference. Can you find the difference between 25 and 2? That's right, 23. So there's subtraction. Fewer is the final word that we have here. And so if I have 3 fewer than Bob, and Bob has 100, well, I'm going to take away 3 from 100. Multiplication. Multiplication words might be times or find the product. When you hear product, we know we're talking about multiplication. Multiplied by, the little word of can mean multiplication. And then finally we have words like double, triple, or take half of something. When I take half of something, I could multiply by 1/2. If I take 1/3 of something, multiply by 1/3. Often people think of division when we use these terms, but you could use it multiplication to represent them as well. Double means 2 times, triple means 3 times, and so on. Division is the operation that seems to have the least number of options. So we might say divided by, or take the quotient. The quotient of 2 numbers is not a commonly used word in the real world, is it? But we find that word in use a lot in math class. And divided into. 3 classes, or I'm going to be taking 1 pizza that has 8 slices and divide it across 4 people or something. So interesting word. These words, taking half of or taking 1/3 of, also often feel like division to us. Taking half of something would be to divide by 2, right? Taking 1/3 would be to divide by 3. Can you put this sentence into a math expression? Can you translate it? The quotient, when the quantity 10 plus a number x is divided by 2. Okay, there are 2 common ways to do this, and the word quantity is really important here. We talked about that in our last class. Quantity means what? You're right. It means it's a grouping word. It means there's some combo happening there, right? And so we would say the quantity. Whoops, I got the wrong tool. Just a second. The quantity 10 plus keyword, a number x. So we're grouping 10 plus a number x. That is the group. Is being divided by 2. So we could literally take and write 10 plus x, right? And then we could use our division symbol is being divided by 2. We're going to find this year that in algebra, we're not going to see this division symbol as often. Instead, we'll just have the fraction bar, which represents division. So we would say, 10, the quantity 10 plus x, right? That whole quantity is grouped above the fraction bar, so I don't even have to show the parentheses. The fraction bar says that's a group, right? Is being divided by 2. And so this is the more commonly seen expression in algebra. Go ahead and translate these phrases and come back and we'll check it out together. Pause the video, come back when you're ready to check it out. So number 2, 8 times a quantity 4 plus a number n. There's that word again, quantity, so I hope that you grouped the phrase that followed, 4 plus a number n. And you should end up with 8. Okay, so do you have 9 minus m, or do you have m minus 9? Which is true? 9 less than a number m. Is this 9 less than m, or is this 9 less than m? And so if I have 9 and I take away m, or I have m and I take away 9, if you answered B, you are correct. Give yourself a pat on the back. All right, and we are beginning to put verbal, real world problems into math equations and expressions. So how does this happen? Well, we take the real world paragraph or problem, and there we have real words, and we try to reduce it down to as few words as possible. That's called a word model. Take away all the extra words, just have some basic single words, maybe in boxes that you're adding up or something. And then finally we substitute math symbols and numbers and variables, and we have our algebraic expression. When we do this, we can use our 5-step plan that we've learned in 6th and 7th grade. At St. John's, we use a little acronym to remember the 5-step plan. Queen Fiona uses outhouse seats. This acronym was created by a group who graduated from high school in 2013, and they graduated from St. John's in 2009. And so what does it mean? Q, ask yourself, Q, what is the question? What is the question in this real world problem? That tells you what your unknown is. If we don't have know it something, then it is unknown, and that would give us our variable. F stands for the facts. Find the number facts that are important in answering the question. And U stands for unnecessary facts. Are there numbers given in this real world problem that are not needed? If so, don't use them, right? O stands for operations. We look for words that represent operations, as we were just talking about in the beginning of this section, right? Look for words that represent addition, subtraction, division, multiplication, right? And finally, S stands for solve and check, right? You are to write your algebraic equation that represents the real world situation, and I can see the real world situation in your algebraic equation. And then we solve it and check it. Okay, so that's how we use Queen Fiona uses outhouse seats, the 5-step plan, to solve a real world problem algebraically. The final term that is introduced in this section is the term rate. So recall what a rate is from pre-algebra. So rate is a 4-letter word related to a 5-letter word. That word is ratio, right? And so rate and ratio, what do you think of? What do you see? Hopefully you're thinking of something that looks kind of like a fraction, right? We're comparing two quantities, but when we're dealing with a rate, the two quantities have different units, different unit forms, okay? So a unit rate is a rate whose denominator is 1. An example would be driving 60 miles per hour. That would be 60 miles per 1 hour. That's a unit rate. Another example would be, you know, 2 Girl Scout cookies have 70 calories per serving, right? And a serving is 2 cookies. So 1 serving, 70 calories. So the denominator would be 1, okay? So let's see, can you take these rates that are not unit rates and convert them to unit rates? I drove to school at 420 miles per 3 hours. So really, how fast was that? We want a denominator of 1, so we simply divide the numerator, right? 420 divided by 3, and you get something big. 3 goes into 4 once, and you have 12, so 140. So the unit rate here is 140 miles per hour. 140 miles per hour. I don't think I really drove to school that fast. Not on my scooter. And I hope not in any of your cars either. Anyway, 20 cups per 8 people. Can you change that to a unit rate? So again, we're dividing 20 by 8. 8 goes into 22 times, right? And then we would have 4 eighths, or 4 eighths could be half, 0.5. So we have 2.5 cups per person, or per people. That's a unit rate. 2.5 cups per 1 person. Notice we don't even include the 1 in the denominator, but we know if I say 140 miles per hour, it's in 1 hour. All right, and you're ready now to do your 2 assignments, and you should have lots of time left. It's a block schedule. So good luck, have fun, and I'll see you tomorrow.